Hello everyone, my name is Joshua Huertas Garcia and I'm going to explain you the drilling units offshore modules. I'm studying in IPN or Instituto Politécnico Nacional for the ESIA, the command. That is ESIA Ciencias de la Tierra. For the table of content, we have first introduction to next SEA deep water drilling technologies, subsea well control system, drilling completion and workover risers, deep water completions and workovers technology, pipe hanger system, and to finish we have a conclusion. Excuse me. For the introduction to the project, we have the hydrocarbon exploration and production in deep water reserves represents one of the greatest technologies challenge in the oil industry. This for the extreme conditions, distance from the surface, and the oceanographic factors complicate the operations, making the use of advanced technologies in drilling control systems, risers, and well completions essential. This analysis provides details overview of the equipment and producers used in these offshore operations. And we have an image with the first ultra deep water well in Mexico. Next, in the drilling technologies in deep water, we have two types of platforms. That is fixed units that they operate in water depths of up to 100 meters, and they are mainly used on developed platforms. And for the mobile units, we have submersibles that is adapted to shallow waters, jack-up platforms that is up to 90 meters with adjustable legs. In semi-submersibles, we have to operate in deep waters and it's high stability. For the drill ships, is a maximum mobility and is used in deep and ultra deep waters. And to finish, we have the TLP, that is a tensional legs platforms. Is designed for a depth of over 600 meters. And for the factors to consider, we have the ocean currents, wave formations, extreme winds, tides, and dangerous water conditions. In subsea well control system, we have the direct hydraulic that is simple, reliable, and limit to a short distance. Next, we have the hydraulic with pilot valves. This a greater danger, but with longer response times. Next, we have the sequential hydraulics that is a reduce the umbilical cord size, limit to operate flexibility. For the case of the electrohydraulic, it's a electrical science to accelerate the response. And finish, we have the multiplex electrohydraulics that is in change to control multiple functions with high speed and precision. Some key components, we have a control pods, accumulators, umbilical system, and surface master stations. Now, in comparative analysis, we have a reliability, installation time, operating cost, and effective control in distance are evaluated. Now, for drilling completions and workover risers, the riser functions. Sorry, we have it is the facilitate drillings, and that is allows of the lower of drilling tools and pipe into the well bore, installing and removing subsea trees, provides a safe channel for handling this critical equipment. And we have a fluid convenience that it's a transport drilling fluids like a mud, oil, and gas from the wellbore to the surface, excuse me, and maintaining the pressure control necessary to prevent uncontrollable bursts. And for the components, we have a main body that is a main pipe through which fluids and tool circulates. Telescopic joints, it's allow the riser to expand and contract due to the vertical movements of the platform. The tension systems, that is a keep to the riser under constant tensions to withstand dynamic lands. In connector, we have that is a low riser section to be assembled or separate quickly and effectively. In auxiliary lines, they carry additional control fluids. It's such as choke and kill lines. The structural design is to ensure the integrity of the riser, and following are performed. We have a static analysis that is evaluate the riser behind under constant load, such as depth, high and internal pressure. In a dynamic analysis, this is the study of the riser's response to variable force such as hubs, waves, ocean currents, and platform moments. These studies ensure that the risers we can withstand the formations, strains, and vibrations during the operations. From the case of the interactions with the motion compensation system, the riser is constantly exposed to a vertical movements of the platform due to waves. To protect it, we have to tensional systems, that is a continuous upward force to keep the riser in optimal tension. For the motion compensator, we have to absorb vertical displacement of the platform and prevent force from the being transmitted directly to the riser. This improving system stability minimizes the risk of damage and extends the riser lifespan. Now we have an image that is a subsea riser systems design, and I put them just for you know how to look. In terminations technology and repair, we have the underwater trees. They are systems of valves and connections installed on the set to a control oil and gas production from a subsea. For this image, and sorry that I put in Spanish, but in the book that I take the informations, this appear in Spanish. So um, I'm talking about of classifications of underwater trees in greatest scale, and we have a vertical that these are the most traditional design. The hydrocarbon flow is directed vertically upward through a series of valves placed one above the others. They are primarily and used when operations and frequency and easy operation is desired. For the horizontal, we have these valves are mounted laterally to the main production tubing. They allow more direct access to the well, facilitating interventions, maintenance, and repair operations. They offer advantage in multi-wells files and allow great operations flexibility. For deep classifications, we have simple trees for small waters deeps less than 100 meters. In diverse assist trees is installed with the help of divers at intermediate depths and is for 60 to 250 15 meters. And finally we have the fully automatic trees for deep waters, like the 515 meters, and the operations without the human assistance. In techniques of terminations, we have the tieback system that is it consists of extending a pipeline that connects a subsea production tree directionally to a floating platforms or unit on the surface. It's ideal for integrating remote well productions into exciting infrastructure, reducing cost. In the multi-line system is a system in which the well casings are suspended directly from the seabed without the need for elevated structure. In facilities, it facilitates the temporary or permanent abandonment of wells and is used in exploration operations and in the feature manufacturers. We have ABB Bedco Gray, Cooper Cameron, and FMC Technologies. Now with a pipe hanger system, first the main functions. The pipe hanger are devices that allow productions tubing to be suspended or supported within the subsea head. This ensures that the production string is properly in position and supported underwater, and the installation methods is first the mechanically, that is done using tools the, that the secure the hanger with physical or mechanical force. In the case of the hydraulic, is use fluid pressure to position and secure the hanger, allowing for a greater precision, especially in remote or deep waters installations. We have types of SEA or seals. These seals ensure no leak between the suspended pipe and the header. The elastomeric, they use flexible materials like rubber. Is ideal for a moderate pressure and easy installation. And in the case of metal on metal, they provide greater strength and durability, especially in extreme environments. For the hybrid combinations, these two are combined the advantages of both, and achieving a good balance between strength, flexibility, and hermetic sealing. And the conclusion. The deep water drillings as driving significant technologies advantages in platform design, control system, riser structure, and completion equipment. Proper selections and operations of these elements is essentially to ensuring operations success, embodying satisfy and cost optimization. Continue innovating in materials, structural designs, and process automatic and critical to the future of offshore developments. And thank you so much for see this presentation. I put my medias for if you have a question, and it's all for my part. Thank you.